Currently, if you have a Kubernetes cluster, you need to use a bunch of different tools to understand what is going on inside the cluster. Typically, you would use kubectl and query the cluster directly to look at all the pods and individual objects inside the cluster, Prometheus and Grafana to see some metrics, and tie all that with log output. And looking at all of those, you can kind of sort of start to get an understanding of exactly what is happening in your cluster. With Dripstat, we wanted to replace all that with a single place where you can understand every single thing that is happening in your Kubernetes cluster. We're looking at the Dripstat Kubernetes monitoring dashboard. We see the list of individual Kubernetes clusters we are monitoring, and we see some useful information like the total memory and CPU available to this cluster and the percentages of each used. Clicking on a cluster, we can see the individual pods in that cluster, and we can even filter it. So let's say we want to see all the pods in the default namespace with a particular label, and we see that list. And not only do we see the names of individual pods, we see all the information about each pod, like the node they're assigned to, the IP, what time they're created, etc. Clicking on a pod shows us all the details for that pod. Here we can see all the state for the pod, and we can see it's running perfectly fine. We see the metrics for that pod and the containers assigned to that pod. We can see this pod has 2 containers inside it. So the metrics shown here are for both the containers combined. If you want to see how much memory and CPU is used by each individual container in this pod, we can group by container. We can even change the chart type and back to original. We can click on a container and we can see details about the container, like the state and the metrics. The metrics for a container also contain the memory limits and requests and the CPU limits and requests. Let's take a look at the workloads on this cluster. We want to see only in the default namespace and only workloads that are deployments. We see there are 5 deployments in this cluster. Let's take a look at the DC deployment. We are looking at this deployment and we can see its state, its metrics, and the pods that make up this deployment. The metrics shown here are cumulative of all the pods that make up this deployment. So we can see right away that this particular deployment is using 5.5 gigabytes of memory. We can see how much of these 5.5 gigabytes is taken up by each individual pod. We can even change the chart type to see that each of these pods is taking up pretty much the same amount of memory. Let's look at all the nodes in this cluster. This cluster seems to have 2 node pools. Let's look at the nodes in the DC pool. Let's go and take a look at this particular node here. And we can see its state, its metrics, and all the pods deployed on this node. The metrics for a node show the allocatable and capacity metrics for CPU and memory. There are a lot of objects in Kubernetes that may not have metrics associated with them, but we still need to see the configuration or the fact that they're present or not. For example, we are looking at the services in our cluster right now. And let's say we want to see all the services in the default namespace that are of type cluster IP. We can see and verify that these services exist right away. We can even look at endpoints. We can see the secrets and config maps deployed to our cluster. Now for these two, we don't show you the contents of the secrets or config maps, but we show you all the configuration around those. So we don't leak any sensitive data. So let's say we want to see the default namespace and all the secrets in it. We see the list of those and the configuration of those, but we cannot look inside those secrets, so all sensitive data is protected. The metrics page allows us to understand the resource usage of our cluster. Here, we are looking at all the resources used by all the pods in a cluster. We can even see the top pods sorted by memory or CPU. We can see that all the pods in a cluster are taking about 16.5 gigabytes of memory. Now let's say we want to understand how this memory is being used. Let's group the memory being used by namespace. We can see that the default namespace is taking up the most of memory. So let's look at only the default namespace for now. And let's group this now by the workload type. And we can see that the deployments in the default namespace are the ones taking up the majority of memory. So let's look at the deployments only. Now let's group this down by the node pool. We see that the memory usage across node pools is pretty similar. Scrolling down, we can sort the top list by memory, and we can see that it's this DC deployment pods that are taking up the majority of memory.